Hello everyone. In our previous video, we have seen the basic data pre-processing steps for natural language processing, like dealing with emojis, removing special characters, removing stop words, and also we have seen the lemmatization, right? So in this video, we'll see how to use TF IDF and build ML model out of it. Now, as usual, first step, right? So when I want to build a machine learning model, we will always start with train and split model, right? So yeah, so I imported the train test list package, and now I'm taking the test size as 20%, right? Yes. Now obviously we should have x-axis and y-axis, which we already know, right? So in this case, the x-axis nothing but your tweet data, and y-axis is nothing but your sentiment, whether positive or negative, right? So I'm taking the train clean tweet and the test clean tweet, right? From this we can also do like this. Why not this? This is actually not required. We can simply take this, right? So this is nothing but our x-axis, I mean x, the train, I can say x train and x test, right? Now what we'll do is, now we'll go for TF IDF. So now we obviously have to build TF IDF for this, the X train and Y train, right? Maybe I'll X train, X test for a more understanding, right? Because we are used with that format. So now in sklearn, under feature extraction text, we have TF IDF vectorizer, right? Now I imported it. Now I'm creating an object vector TF IDF. I'm saying was use IDF equal to true, right? And then now this x train equal to this vector, come on, okay, let me type vector dot fit underscore transform. I'm transforming on the x train, right? And of course I need to convert my test data also, obviously, but this time I won't say fit, I'll just say transform. Transform of x test. Got it? You know why? So obviously in the test data I won't apply fit transform. Usually what fit does, it will calculate the required term frequency and identity document frequency, and transformation will convert that. So will apply those TF IDF values to my dataset. But when you talk about test data, I won't calculate the TF and IDF on my test data. I'll apply the calculated TF IDF on the train data, right? So where I'll be calculating the TF IDF on the train data, those TF IDF I'll be applying on the test data, right? And why we are not calculating TF and IDF on the test data? Because we know technically test data is an unseen data to my model, right? Maybe I can say that's a new data that my model never seen, right? Obviously, how can I calculate the TF IDF on the unseen data, right? So I have to calculate the TF IDF on my seen data, which is nothing train data. So whenever the new data comes to my model, right? So then I need to apply TF IDF, which I calculated on my train data, right? And this is how it works, right? Even for when you talk about the normalization, standardization, anything which you're applying on the train data, right? the values which, like when you talk about min max scalar, right, for the scaling. So what I'll do, I'll calculate the minimum value and maximum value on my train data, right, when I say fit, and when I say transform, right, so what are the minimum value, maximum value I calculated, I'll apply those calculations on my train data. Now the same minimum value, maximum value which I calculated in the train data, I'll be applying on my test data, because we know the test data is unseen data, the data that comes once my model is trained. And there is no point of calculating the mean and maximum value for the test data, right? So now let me run this. It says X train is not defined. Okay, we have to run this, right? And X test. Now if you see, if I run this, it says it's some object, it's an numpy object, right? So now we can see the data. If we want, how we can do is dot to array. We can see a big array, right? And you can see the shape, right? So we have total 7,999 rows and 9,508 columns, right? Which is such a huge, data. And if you see, it says sparse row. When you talk about sparse matrix, when you have more zeros, ones and zeros, then we call it a sparse matrix, right? And you can also see, what are the columns, the name of the columns, right? It is something like your vector object get future names. Yeah, no, it's method. See, so these are the almost 9,000 plus columns that we have, right? So now anyways we are not worried about that. So what we'll do is, now maybe we'll build a function, right, that takes our trained model, right, and it will predict on the test data and it will give the accuracy, right? Of course we still had to develop the model, but still, right, we are just creating a function, right, model performance. So where I am taking model, which is a trained model, right? Now I can predict equal to model dot predict, right? So I am predicting my test data, obviously, right? And we have to calculate the accuracy. So usually if you remember, right, if you're aware how classification accuracy works, we would either go for precision, recall, false negative rate, false positive rate, and maybe some AUC, ROC curves, right, or reference scores, but mostly we never go for accuracy. And why we go for those different matrices, in case if you're not sure, please make sure you watch my video on classification accuracy. I'll keep those the video link in the description, right? So now let me calculate the accuracy. Yeah. So this is y test and x test sentiment. We know we have two columns. One is text and sentiment. Text is our actual text, our actual data, and sentiment is, it says whether this is positive or negative. And the similar way, so we need to calculate, so I'm the recall and precision, right? Now I'm just simply returning as a tuple list accuracy, recall, precision, ACCU, accuracy, precision, recall. So now I obviously need to import the the required packages for accuracy, precision, and recall, right? This is the one. Let me import it here. We are not using reference code, and I'm not calculating the confusion matrix. What I need is an accuracy score, right? So now now the next step is, now maybe we'll try with the different models. Maybe I'll use different linear models here like naive SVM and the logistic regression. The reason why I'm not using tree based models is because obviously in the local machine it will take some decent time, right? So our intention here is in this video series, the Twitter sentiment analysis series, not to learn the machine learning, in fact to see the end-to-end, you know, the life cycle of the model deployment, right, from data gathering and the real time pushing it S3, right, and see how it works end to end, right? So one of the assumption of seeing this video is you should be familiar with the the different machine learning algorithms. In case if we are not sure what is machine learning, how it won't work, so please make sure that you watch one of my playlist called the data science, which I talked about the basics of machine learning, all those things, right? So now I'm here in this model training. I'm using binomial model, SVC model, support vector machine, and logistic regression model. I'm using three different machine learning models, right, where I created an object for this, right? Now I'm creating a list of this three model objects, right? And now what I'll do is, as we know, we'll simply use simple for loop and we'll iterate over this list, and then we know what is in the model. In this model we'll have binomial model, SVC model, and logistic regression model, right? Dot fit we know it's xtrain comma xtrain of sentiment, right? And then now obviously what I need to do, I need to call this function, right, where I'll pass my model, which is my train model. We know the fit will train the model. This particular model we are passing to the our function we just created that will calculate the accuracy score, recall, and precision, right? And then we created a list. In this list what we'll do is we'll keep the accuracy score, right? So now obviously in this list I need to keep the score in such a way, okay, for binomial model this is the score, for SVC model this is the score, for LR model this is the score. Now when you see this, right, this model is nothing but one of this object, right? So if I see this, I'll get something like binomial model and those parameters which we just passed. So there is an option how I can do is if I want to get the my model name, which is the algorithm which I used, right, I can say class dot name, right? Got it? Now what can I do is here I'll say model dot, because it's a dictionary, right? Obviously it's a key comma value pair. My key would be my name of the machine learning model, right? Not just all this parameters, equal to what I'll do is I'll call my accuracy. See, whether I want to use recall or whether I want to use precision, that totally depends on our use case, right? So I'm just randomly trying to use the recall in our case, which is 1, because this is a tuple, right? Now now we are getting this. Let's run this once. Let's see what error we get. It says invalid syntax. It says model.fit. Maybe this line number 22. I'm just checking. Got it. So now see, obviously see the mistake which we are doing is we are saying xtrain of sentiment, right? Obviously xtrain has only one column, which is the text, right? When you see here, we are just taking the text. It should be train, just train, and here it should be just test. has no binomial object, has no attribute predict, obviously, because the spelling mistake, PREDICT, no problem. Accuracy score is because we did not run this, we just imported it, but we didn't run it. Yeah, name accuracy is not defined, where it is saying accuracy. Again spelling mistake. See how many spelling mistakes I'm doing. Yeah, it's running now. No spelling mistakes, right? Yep, it ran successfully. Now we have it, we already created dictionary called model scores. We can run and see what it is, right? And this binomial NB says 90%, linear SVC 87, logistic regression says 88% accuracy. So this binomial naive Bayes has given the good accuracy now. Now obviously we have to take the best model out of it, right? So now what we can do is simple. So best model equal to max of, so this is one of the what do you call method that will give you the maximum value in the dictionary, right? So now obviously we need a key, right? So we need a key, I mean nothing but the model name which has good accuracy. Model scores, I'm sorry, this must be key equal to get. Yeah, now in the best model you can see obviously binomial naive Bayes, right? Because it is more recall. So now the next thing we have to do is obviously we need to save our machine learning model, and also we need to save our TF IDF vector. Obviously, as I said, right, whenever the new data comes, right, for the predictions, so when we want to deploy our machine learning models, obviously we need the best model along with the the TF IDF vector, right? Because whenever the new data comes, I need to apply this TF IDF on the new data, right, which we already calculated on the trained data. Now we'll save the model. What we can do is file name best model plus maybe we can save it as a pickle, obviously, PICKLE. We'll see how the file name looks. Yeah, PICK, again spelling mistake, see, PICKLE, right? So now we know how to write a file with open, right? And I would like to save in a particular folder, maybe, yeah, maybe I'll try to save in this particular location, right? As model. Now we should use pickle.dump. Now PICKLE pickle.dump. I'm dumping my model, right? I think we should also store our model maybe in some kind of dictionary. Right, so you'll understand in some time what I'm trying to do. Not required. This is again a dictionary. Model. Let's run this again. It ran successfully. You will see what is present in the model file. right? So it's a dictionary, as I said, key comma value pair, right? It has three models, a fitted models. So we are saving a trained model in this dictionary. Now when we are dumping here, what we can do is this one, and we are passing the key, right? So best model, this is the best model where I have, you know, the best trained model, right? So this is one of the key in my dictionary on model fitted. So obviously that particular model will be saved, right? And yes, model, let me write a model here. Now we already have a model variable defined. So now we obviously have to import the pickle. Let me run this as expected. What is this? It says permission denied. Yeah. So now we saved our model, the best model, and our TF IDF vector, right? So hope you enjoyed this video, right? So now we train the model, right, and we exported the best model along with the TF IDF vector. So in the next video, what we'll do is we'll try to deploy our model. We'll try to expose our model as a REST API, and we'll deploy an EC2. So till then, please don't forget to subscribe to my channel. Thank you.